quickly differentiate me between the three types of bonding: ionic, covalent, and metallic. Quick.
Yeah.
Tell me what's the difference between metallic, ionic, and covalent bonding?
Metallic bonding has is only between metals. Ionic is between metals and non-metals, and covalent is only non-metals.
Good. So today we'll be starting off with your topic number 3 of unit 1, paper number 1. Okay. So P1, topic 3. There are total of 5 topics of your paper number 1. Today we'll be starting off with topic number 3, which is bonding and structure. In
Yeah.
this chapter, topic 3 is divided into 5 parts: ionic bonding, covalent bonding, and shapes of molecules, along with metallic bonding and solid lattices. We'll try to cover 3A and 3B today, and the rest would be done tomorrow. So, how do these cations and anions basically form? We know that cations are the positive metal ions which are formed by the loss of electrons, and anions are the negative ions, metal ions, which are formed, or the non-metal ions actually, which are formed by the gain of electron. Some ionic compounds can be formed by the direct combination of two elements. For example, formation of sodium and chloride ions, and they can be formed by burning sodium and chlorine. We can represent the reaction that occurs by two half equations. For example, you can see over here Na plus 2Na 2E and Cl2 2Cl. One of them is being oxidized, the other is being reduced. Oxidized means loss of electron, then reduced ka matlab is gain of the electron. In this
Yeah.
equation, you can see each sodium atom has lost one electron to become a positive sodium ion, and the chlorine molecule has gained two electrons to become two chloride ions. We can represent the electronic changes involved by the dot and cross diagram. So here you can see there is a plus charge on sodium, and now its outermost shell is empty because that electron went where? It was lost by sodium but gained
Lost.
by chlorine. So
Yep.
this is now a sodium ion, and this is not a chlorine ion, it's a chloride ion. You always add ide to the non-metal. So for example, magnesium and oxide ki bhi dekh lein. Magnesium is in group number 2, it can lose 2 electron, and oxygen is group number 6. It has to gain 2 electrons. So this is the kind of dot and cross diagram that you see for magnesium oxide. When magnesium loses 2 electron and oxygen actually gains those 2 electron. Ionic bonding occurs in solid materials consisting of a regular array of oppositely charged ions extending throughout a giant lattice net. The most familiar ionic compound is sodium chloride, and it consists of a regular array of sodium ions and chloride ions. We call this structure what? Lattice.
That is.
Lattice is a regular arrangement of all the positive and the negative ions arranged through electrostatic force of attraction, because unlike charges are always attracted towards each other. The diagram on the left is an exploded version of the structure as well, which is drawn for clarity. So one thing you should know, that in an ionic solid, there are strong electrostatic attractions between the ions, and the ions are arranged in such a way that the electrostatic attractions between the oppositely charged ions are greater than the electrostatic repulsions between the ions with the same charge. The electrostatic interaction between ions is not directional, and all that matters is the distance between the two ions, not their orientation with respect to one another, that how much are they actually far away affects their electrostatic interaction as well, then the size of the ions as well, then the
Yeah.
charge on the ions as well. If we talk about sodium and chlorine, and if we compare it to magnesium and oxygen, now obviously they are going to have a stronger electrostatic force of attraction due to greater nuclear charge as well. When ions are present, the electrostatic interaction between them tends to be dominant. However, it is possible for there to be significant covalent interactions between ions. So you should think of pure ionic bonding as an idealized bonding situation. So strength of ionic bonding ko dekhein, we can calculate the strength of the ionic bonding by calculating the amount of energy required in 1 mole of a solid to separate the ions to infinity in the gas phase. When they are at an infinite distance from one another, the ions can no longer interact. So here you can see the amount of energy required to separate the infinity the ions in 1 mole of various. और यहाँ पे आप देख सकते हो fluoride. ठीक है, it's the most electronegative as well. It has the
Mm-hmm.
smallest shell as well, because as you move down the group, what happens? The size
Uh,
of the atom is actually increasing. which means
Increasing, yeah.
lesser attraction between the nucleus and the electrons as well.
Mhm.
So the energy is getting
If they
weaker.
are far further away.
Exactly. Fluoride is the strongest. Then if you look at group 1 as well, same is happening in group 1. Lithium is the strongest one because it's the smallest. And then you can see rubidium. Okay, rubidium has the 4 shells होते हैं. Period number 4 में होता है. So it has a lesser, obviously, energy. So for ions of the same charge, the smaller the ions, the more energy is required. A very important point related to exam. What? Smaller the ions, more energy is required to overcome the electrostatic interactions between the ions and to separate them. The
Yeah,
size of the
because the
ions is
force of
one
attraction
factor
is
that
much
affects
stronger.
the strength of ionic bonding. So one factor क्या हो गया? The size. That also
Yeah, size.
determines exactly atomic radius.
Mhm.
ठीक है? Or much better word is ionic radius actually.
Yeah.
The lattice energy for lithium fluoride, if you look at this, the lattice energy of lithium fluoride is 1031. But if you look at magnesium fluoride, it is 2957. Why? Because magnesium was 2 plus, lithium was
Mhm.
1 plus. They both had fluoride. But why is MgF stronger? Because greater nuclear
They have,
charge.
yeah.
Even though the size is also the same, ठीक है, आपका lithium है, and in the same period we have magnesium as well also, ठीक है, तकरीबन. But again, the size is similar, लेकिन increased charge of magnesium ion compared to the Li plus ion is a significant increase in the strength of ionic bonding. तो second factor क्या हो गया for the strength of ionic bonding? The charge. The first one
Charges.
was size,
Atomic radius
good, and the second one is
and
charge.
is charge.
When both cation and anion are doubly charged, the energy required to separate the ions is even more. For example, first हमने क्या देखा? Lithium plus F minus. Okay. Then we looked at Mg plus 2, F minus. Now, suppose both of them are 2, 2. This would be the strongest then. For magnesium oxide, it's 3791. So there is no simple mathematical relationship to describe the effects that the ionic radius and ionic charge have on the strength of ionic bonding. The situation is complicated by the way in which the ions pack together to form the lattice and by the extent to which there are covalent interactions between the ions. In general, however, the smaller the ions, the larger the charge on the ions, the stronger would be the ionic bonding. A very important line. Got it?
Yep.
Good. So what is the evidence for these existence of ions? We can tell it and prove it by electrolysis that two types of ion exists, a positive ion and a negative ion. How do you think electrolysis proves this?
Cation and anion.
How does electrolysis prove it?
The positive ions will then attract to the negative side,
Good.
and the positive one, no, negative one will go to the positive sides because
Exactly.
opposite
For
charges
example,
attract.
exactly. When you pass direct electric current through a molten sodium chloride electrolyte, sodium is formed at negative electrode, chlorine is formed at positive electrode. So this explains us that charges exist. The explanation for this phenomena is that the positive sodium ions migrate towards the negative electrode where they gain electron and become sodium atoms, whereas the negative chloride ions migrate towards the positive electrode where they lose electrons and become chloride molecules. For example, negative electrode पे क्या हो रहा है? Reduction. And then positive
Yeah,
electrode के ऊपर oxidation. ठीक.
oxidation.
So overall equation becomes this. We can demonstrate the movement of ions by passing a direct current through copper chromate solution as well, where we have copper 2 plus ions and chromate ions. और इन दोनों के अलग अलग कलर जब प्रोड्यूस होंगे, you can tell कि ठीक है, copper 2 plus ion is a positive ion that has been produced and chromate भी आपके पास produce हो गए, something like this. आपके पास दो कलर्स appear होने लग जाते हैं, which proves that the color of copper chromate was green, but copper 2 plus ions यहाँ produce है because blue color. Chromate 2 minus ions are also produced. It's a proof that it has a yellow color as well. So the colors can also identify as well. The copper ions migrate towards the negative electrode as they are themselves are positive, and the solution around this electrode turns blue. The chromate ions migrate towards the positive terminal in the solution, and around that the electrode turns yellow. Evidence of ions is also supplied by electron density maps. What is an electron density map? It shows how the ions are separated from one another. It can tell you the size, the atomic radius, and we'll discuss that when we'll see the questions for this because it's a very rare one. So remember, There's a very big misconception. Ionic bonding, people think, is the transfer of electrons.
Mm-hmm.
It is the transfer of electrons, but ionic bonding ka process, this is the process for ionic bonding, transfer of electrons. After the
Yeah.
transfer of electrons have been done from atom to atom, one of them has become a positive ion, one of them has become a negative ion. Now
Negative
the
ion.
electrostatic attraction between them after the transfer of electron, that attraction is known as ionic bonding. Don't
Ionic
write
bonding.
that ionic bonding is transfer of electrons. Don't.
Yeah.
Covalent is sharing. It is correct that
Mm-hmm.
covalent bonding is the sharing of electrons. That is correct. Ionic bonding is not
Mm-hmm.
transfer of electrons. The product formed after the transfer of electrons, we have a positive
Is
ion, we have
ionic
a negative
bonding.
ion. That electrostatic attraction between unlike charges is the ionic bonding. Transfer of
Mm-hmm.
electrons is just the process of forming
Yeah.
ions. Got it? Don't
Mm-hmm.
confuse that.
Yep.
You can do this
But
checkpoint after the class as well.
covalent is always shared because they are always sharing.
Yes, covalent bonding definition is simple, sharing of electrons.
Okay.
But for ionic, don't write its transfer of electron. Right?
Yeah.
It's the electrostatic attraction between positive and negative ions after the transfer of electrons.
Yep.
Next, we have ionic radii and polarization of ions. So trends in ionic radii देखें. Ionic radii are difficult to measure accurately and they vary according to the environment of the ion. For example, it is important how many oppositely charged ions are touching it. What's the coordination number? Coordination number matlab the valency or how many bonds have they formed. There are several different ways of measuring the ionic radii and they all produce slightly different values. If you are going to make reliable comparison using ionic radii, all the values must come from the same source. Remember that there are quite large uncertainties when using ionic radii. Trying to explain things in detail is made difficult because of those uncertainties as well. So here you can see group 1 ions and group 7 ions. What difference can
Yep.
you see in their ionic radii as you move down?
Uh, they're becoming bigger and bigger.
Good. And what about anionic radius?
Same. They're also coming bigger and bigger.
Good. So period number 2 के अंदर हम देखें what is happening across the period?
They're becoming smaller.
What is happening over here as well?
They're also becoming smaller.
Now give me the reason for both of the group trends as well and the period trends as well in detailed reason. Come on.
In the groups, they become because there are more shells,
Good.
so they will have a bigger electrostatic
Now periods.
and periods.
You've done it in
Mm,
ionization energy. It's very easy.
yeah, I know. Uh,
Electrons are increasing from left to right.
yep, yes, electrons and protons are increasing.
So nucleus brings them closer.
Mm-hmm.
So shell becomes closed. Shell number remains the same. Number of shells are
Yes,
the same. Sodium,
but if
magnesium,
there are
aluminum.
more, but
Yes,
if there are more electrons, they will have a stronger attraction.
exactly. Sodium, magnesium, aluminum, all of them have three shells. They are all in period number
Yeah,
three. But aluminum has more closer shells than sodium. It has a higher nuclear charge as well, more number of electrons as well, and more number of protons as well. 13 protons, 13 electrons की attraction है ना. Sodium में 11 protons in the nucleus attracts 11 electrons. So all the six ions listed in table B are isoelectronic. Isoelectron means they have the same number of electrons and same electronic configuration as well. Nitride, oxide, and fluorine, they all have same number of electrons. So ionic radius decreases as the number of proton increases across the period. This is also one reason. Simple आप लिख दो proton increase कर रहे हैं. As the positive charge of the nucleus also increases from +1 to +2 to aluminium +3, the more strongly they are, therefore pull closer to the nucleus. Got it?
yeah.
Can you tell me what do you understand by the term polarization?
Uh,
Charged. In an ionic lattice, the positive ion will always attract the electrons of the anion. That is simple. If the electrons are pulled towards the cation, anion is said to be polarized. Since the even distribution of electron density has been distorted. अब देखो ना, we have a cation
mm-hmm.
and we have an anion. ठीक है, anion has
Anion.
electrons. Now the structure is going to be distorted if the cation is trying to attract anion. This electron is going to come over here. All of the electrons are going to come on which side?
On left side, the closer one to the cation.
Exactly. You have done this in physics IGCSE as well. The spheres,
Yeah.
it's the same thing. So this is known as the Fajun rule, and we have to summarize over here. Look at this. Can you explain me what's happening in this diagram?
The anion is pointing to the cation
Good.
because that's
Polarization
the
will be
direct.
increased by a high charge and a small size of cation, a high charge and a large size of anion. Smaller the cation, higher the charge. Larger the anion, higher the charge. So it's important for the cation to be the smallest, anion to be the largest. That would be the best polarization. The ability of a cation to attract electrons from the anion towards itself is called as polarizing power. A cation with a higher charge in a smaller radius has a larger polarizing power. An approximate value for the polarizing power of cation can be obtained by calculating its charge density. The value of charge density of a cation is the charge divided by the surface area of the ion, and the surface area of the ion would be equal to 4 pi r square, where r would be the ionic radii. So remember, charge density is directly proportional to the charge, but inversely proportional to the radius. High charge and small size of anions कैसे affect करेंगे? Because they would be polarized more easily. पहले तो हमने देख लिया कि small size of cations कैसे affect करें. Now small size of anions क्यों? Because the degree of sharing of electrons will become easy as well. It would be easy to attract, it would be easy to lose, and all of that. So, important definition: polarizing power is the ability of a positive ion to distort the electron density of a neighboring negative ion, and polarization is the distortion of the electron density of a negative anion. Got it?
Yeah. Yep.
What properties do you remember for ionic compounds? Is the same as IGCSE. I'm going to just make it very quick. Tell me. Tell me the properties of ionic compounds quick.
The ionic compounds have high melting temperature and bad conductivity. Uh,
You sure
uh,
all of them have a bad conductivity?
that was what we learned, I think.
You think all of them are bad conductors? All ionic compounds?
Yes, solid ones at least.
Solid ones, yes, they are not conductors. But when they are in molten form, they can conduct electricity, like electrolysis. Got it?
Yeah.
Solid ionic compounds cannot conduct electricity. Molten ionic compounds, जो वो liquid form में, they can. Ionic compounds typically have the following physical properties: high melting temperature, brittleness, poor electrical conductivity when solid, but good when molten, and often soluble in water.
Yeah.
And now examiner can ask you the reason for any one of them. Okay, he's going to give you two random compounds and are going to compare. High melting temperatures, why? Ionic solids consist of a giant lattice network of oppositely charged ions. There are many ions in the lattice, and the combined electrostatic forces of attraction among all of the ions is large. A large amount of energy is required to overcome the forces of attraction sufficiently for the ions to break free from the lattice and slide past one another. If a stress is applied to a crystal of an ionic solid, then the layers of ions may slide over one another as well. High melting temperatures की reason क्या थी? A large amount of energy is required to overcome the forces of attraction. I need the same exact answer when you solve the paper. Got it?
Right.
Brittleness, easily breakable. ठीक है? Because when you apply pressure or when you apply stress, layers can slide over each other and they are going to repel. अब जब ये slide करेंगे, imagine right now the positive ion is sitting on the top of a negative ion, right? But when they slide, positive is in front of positive, negative is in front of negative, positive in front of positive, it's gonna repel, and that is why it's
Mm-hmm.
going to break. Got it?
Yep.
Ions of the same charge are now side by side when they slide over, and now they are going to repel one another. पहले क्या था?
Yep.
Positive facing negative, positive facing
Negative, so they
negative,
would attract.
negative positive, negative positive. लेकिन जब वो slide हुआ, ये यहाँ गए, ये यहाँ गए. Now what happened?
Yes, so they would just push each other away.
Exactly. अब वो कुछ ऐसे हो गए. Now they are going to
Yeah.
repel each other. Electrical conductivity. Solid ionic compounds do not in general conduct electricity. This is because there are no delocalized electrons, and the ions are also not free to move under the influence of an applied potential difference. However, molten ionic compounds will conduct, since the ions are now mobile and will migrate to the electrodes of oppositely sign when a potential difference is applied. Ionic compound कर सकते हैं. The best example is the electrolysis, क्योंकि अब आपके पास free electrons हैं. In molten form, you have free electrons. And electrons are
Yeah.
the ones that always carry the charge. Solids may there are no free electrons. Simple answer. It's not even that tough. Take it, no free electrons.
Mm-hmm.
Aqueous solution of ionic compounds also conduct electricity and undergo electrolysis since the lattice breaks down into separate ions when the compounds dissolve. Why are they soluble? We are going to see this in the overall the next year as well, jahan pe hum entropy changes or lattice energy, you have a whole separate chapter. It's known as entropy changes and Gibbs free energy, where we are going to discuss next year A2 ke andar regarding how the particles are disordered from each other. At the moment, you just need to understand that the energy required to break apart the lattice structure and separate the ions can in some instances be supplied by the hydration of the separated ions produced. Both positive and negative ions are attracted to water molecules because of the polarity that water molecules possess. For an explanation, a polarity क्या होती है? When ions separate, they become charged as well. Water है, water भी तो polar molecule है. एक तरफ partial positive है, फिर एक तरफ आपके पास partial negative charges भी होंगे ऑक्सीजन के. So it's also charged. फिर ionic compound भी charged होता है. So they charges attract with water molecules as well. So they become polar. Got it?
Yeah.
Good.